Hello everyone. In this video, we will study how to calculate space required to execute an algorithm. In previous video, we have seen 5 criteria upon which we can judge an algorithm while writing an algorithm. So apart from that, there are two main criteria on which we can analyze the performance of an algorithm. The first one is space complexity and second one is time complexity. So space complexity of an algorithm is amount of memory it needs to execute the algorithm. So when we create any algorithm, depend on how much memory it requires to save that algorithm, the space complexity is calculated. Similarly, time complexity of an algorithm is the amount of time it needs to execute the algorithm. So when we create any algorithm, depend on how much time it requires to execute that algorithm, the time complexity is calculated. Now we will see how to calculate space complexity of an algorithm. So space complexity of an algorithm is depending on two parts. First one is fixed part and second one is variable part. So first part, that is fixed part, is independent of characteristics. That means this part is based on instructions space required for the algorithm. Instruction space means the amount of space required to save the all statements written in the algorithm. So basically, when we complete our algorithm, the statements written in that will be fixed and space required for the algorithm is considered as instruction space. Fixed part is also depending on constant variables whose size remains the same throughout the algorithm. So when we use a variable and that variable requires fixed amount of space, also comes under fixed part while calculating space complexity. Now we will see the second part, that is variable part, and it is the important part while calculating the space complexity. It is a variable whose size is dependent on the particular problem instance being solved. That means size of variable is depend on the input. So when the value of input changes, the space required by that variable also changes. This is the formula for calculating space requirement of any algorithm. That is SP equal to C plus SP. So here C is the constant value, or you can say fixed part, and SP is the variable part that may change depend on input values. Now we will take few examples to understand how to calculate the space complexity. So here we are taking one parameter and then in algorithm we are multiplying a with a and then we are returning the value. We can take one word for calculation, that is for each variable the space required we can consider as one word. The formula for calculating space complexity which we know already, is S of P equal to C plus SP, where C is fixed part and SP is variable part. Now we will calculate the space complexity for this algorithm. So in this example, how many variables are there? Only one variable, that is A. And if you see, the space required by variable A is fixed. That means the size of A remain constant. And as we know, for one variable we are considering one word space for counting. So A required one word, and there is not such variable whose size may change depend on input. So as per given formula, there is only one constant value and SP value remains 0. So we will put values in the formula. So S of P equal to 1 plus 0, where C is 1 and SP is 0. So S of P is equal to 1. So space complexity for this algorithm is 1. So in this way, we can calculate space complexity. Now we will take another example. So this is the given algorithm. We are taking 3 inputs A, B and C, and then we are performing arithmetic operations with them and then returning that value. So this is the formula to calculate space complexity, and in this algorithm there are 3 variables A, B and C. Again, if you see, the size of every variable is fixed. So A takes one word, B takes one word and C also takes one word, and there is not such variable whose size may change depend on input. So as per our given formula, constant value, that is C is 3 and SP value remains 0. So we will put values in formula. So S of P is equal to 3 plus 0, that is S of P equal to 3. So space complexity for this algorithm is 3. This is another algorithm. Here we are taking A, that is array, and N as a parameter, and then we have taken one variable S and initialized by 0. Next we are taking one for loop and it will repeat n times. In that we have used variable I, and in for loop we are adding the value of A of I in S, that is n times we will repeat, that is we will add the value of A of I in S, and finally we are returning the value of S. So this is the formula to calculate space complexity, and in this algorithm there are 4 variables, that is A, which is array, N is for size, S is to calculate sum, and I to repeat the value. So here size of N is fixed, that is it requires only one word. The size of s is also fixed. Even the value of s may change in the algorithm, but the space required for s is one word. Next, just like variable s, even I is also of fixed size because values stored in that may change starting from 1 to n, but I requires only one word space. So all these three variables require fixed size. Next, there is another variable a which is an array, and this variable's size is depend on the input value. That means depend on value of n, the size of a may change. So if n is 10, then a variable requires 10 slots in memory space starting from a of 1 to a of 10. If n is 100, then a variable requires 100 slots in memory space starting from a of 1 to a of 100. So the size of a is depend on value of n. That means a requires n word space. So this algorithm requires 3 word fixed size and n word variable size. So we will put the values in the formula. So S of P is equal to 3 plus n. So here the value 3 is constant, that is the size of n, s and I that will remain fixed in the algorithm, but sp, that is variable size, it may be depend on the value of n. Means once the value of n is changed, automatically the size required by variables may change.